I welcome you all for the lecture on different mass transfer operations. I am Dr. Srinivasan M, Professor and Head of Chemical Engineering, Hindustan College of Engineering and Technology. In these different types of mass transfer operations, I am going to tell you about the classifications, how the mass transfer operations are classified, methods of operations based on the classifications, and the introduction about some of the operations like gas absorption and stripping, liquid-liquid extraction, leaching, distillation, humidification, drying, and crystallization. At first, how the mass transfer operations are classified. All the classification of mass transfer operations based on the need of the industries in the process. The process involving a group of operations or a single operation for separating the components of the mixer. Based on the transfer of material from one homogeneous phase to another or within a phase, these operations are classified. Here, we have to consider all the three phases: gas, liquid, and solids. By allowing the phases by direct contact of two immiscible phases, phases separated by a membrane, direct contact of miscible phases, use of surface phenomena, these operations are classified. Based on the phase of contact, like gas liquid, fluid solid, liquid liquid, solid liquid, liquid water vapor, solid gas, and the other operations like diffusion of a solid from a liquid or gas. Based on in phase of contact, the different methods of operations are categorized. According to that, the important operations are distillation, absorption and stripping, adsorption and desorption, extraction, leaching and crystallization, humidification, dehumidification, drying, and membrane separation. At first, absorption. The absorption is the very industrially important operation and it involves the bulk phenomena. The bulk phenomena is nothing but the solute present in the air is contacted with the third solvent completely. That means the entire surface. For example, if CO2 is present in the air, we may consider this as the polluted gas which contains CO2. We can able to absorb that CO2 by means of third solvent like water, use of adsorption tower. That only clearly indicated in this figure. Like that, so many examples. The one another example is separation of ammonia from its mixture. Here, water is the one of the best solvent for the absorption operation. The stripping is the reverse phenomena of absorption. Here, the gas solid from the liquid phase is separated. Adsorption. The difference between this adsorption and the absorption is the adsorption is the surface phenomena and the absorption is the bulk phenomena. Here, the particle is going to be adsorbed, is called as adsorbate, and the material used for the adsorption is called as adsorbent. Why we are saying this is the surface phenomena? In most of the cases, or almost all the cases, the adsorbate does not went into the interior of the adsorbent, only attracted towards its active surface. There are so many examples for the adsorption operation. The elimination of toxic gases and deodorization of air, recovery of solvents, removal of ions from solution as in demineralization of water, fractionation by selective adsorption of gases, vapors from gases, vapors from vapors, and liquid from liquids, and many other applications. And then desorption. This is the reverse phenomenon of adsorption. The adsorbate is going to be removed out from its active surface. That means the attachment of the adsorbate over the adsorbent is going to be removed by means of desorption operation. Extraction. This is nothing but separating the liquid constituent present in the liquid solution by contact with the another solvent, that is insoluble liquid. You try to see the figure. The liquid solution, that is feed, is going to be contacted with the third solvent. The solvent rich layer, that is called as extract, the extract which contains solvent and the liquid to be separated in the liquid solution, or solid to be separated in the liquid solution, and the residue, the remaining residue which contains the feed and the little bit of solvent and the unseparated solute is called as raffinate. The examples of extraction are the separation of aromatics from kerosene based fuel oils, the production of fuels in the nuclear industry, the separation of penicillin from fermentation mixes are the examples of extraction technique. Leaching. It is nothing but the separation of the finely divided separation from the finely divided solids with a liquid. For example, the feed which contains the finely divided solids. If you want to separate any one in this feed by applying the third solvent, the solvent which separate that particular component, that is called as solute. The remaining things are called as residue, which contains solid and the liquid. The example for the leaching operation is nothing but extraction of oil from oil seed, extraction of sugar beets, extraction of medical compounds from the plants, roots, leaves and stems. Don't forget that the treatment of a finely divided solid with a liquid is called as leaching. Distillation. The separation of the constituent based on its boiling point difference or volatile matter difference. You refer the figure. The feed is introduced into the distillation column and it is separated by the application of heat. The low boiling point component which comes out as a vapor and it is condensed, then it is called as distillate. For improving the operation, the part of the distillate is recycled into the distillation column and then bottom product is reboiled and it is recycled into the distillation column for achieving the heat economy. The best example is processing the crude oil for getting its various fractions like kerosene, fuel oil, lubricating stock, etc. And the separation of a mixture of methanol and water into its components. Humidification. The enrichment of water content in a gas stream taken place by passing the gas over a liquid. That only the figure indicates. The example of humidification operation is the transfer of water from the liquid phase to the gas phase of a mixture of air and water vapor is a widespread application of humidification. The dehumidification is the reverse, which involves the transfer of water vapor from the gas phase of the liquid phase. The example is removal of water vapor from air by condensation of a cold surface and condensation of carbon tetrachloride out of a stream of nitrogen are examples of dehumidifications. Drying. It is the removal of relatively small amount of water from the wet solids by the application of hot air or steam. The evaporation is concentrating the solution. That means the removal of relatively large amount of water from solution. There is a difference between drying and evaporation. In this drying, the removal of small amount of water from its wet solid, and the evaporation is the removal of relatively large amount of water from solution. That means concentrating the mother liquid. The drying is removal of small amount of water vapor, and the evaporation is the removal of large amount of water from solution. That is the main difference. Here, in the case of evaporation, the water is removed as vapor at its boiling point. But in the case of drying, the water is removed below its boiling point. Crystallization. The process of high temperature heating and sudden cooling is called as crystallization. When we are doing this high temperature heating and sudden cooling, there is a process like the difference in solute concentration and its solubility at a certain temperature may happen. There, the solid crystals are formed from the liquid solution which contains solute. Or else, the temperature at which the solute concentration in the solution is higher than its solubility, the crystals are formed by the solutes coming out from the solution. The figure indicates the same. Thank you.